Chapter 20: Sustainable Energy. Because of the environmental problems associated with conventional energy sources, many countries, industries, and individuals are converting to more sustainable sources. These include solar, wind, biomass, and hydropower. We will take a look at each one in this chapter. Before discussing sustainable energies, we should discuss advancements in the efficiency of our appliances. Switching to sustainable energies has been coupled with these improved efficiencies. For example, modern LED light bulbs use 90% less energy than a conventional bulb and last 20 times longer. Computers and TVs are now Energy Star compliant, meaning they use less energy than in the past. All of these reduce the amount of energy we need, making it easier for sustainable sources to meet our needs. A pie graph of standby energy consumption. Improvements in buildings have also reduced our energy consumption. Green building can use up to 90% less than a conventional building. In the U.S., we use LEED standards to guide the construction of energy-efficient buildings. LEED is an acronym for Leadership in Energy and Environmental Design. This certification system was developed by the U.S. Green Building Council as a way to ensure buildings meeting certification standards are truly efficient. Besides construction, automobiles have also become more efficient. Transportation in the U.S. accounts for 40% of all oil used and 20% of the CO2 production. Any changes in fuel efficiency will have significant impacts on the environment. However, consumption of gas tends to be related to the price. As prices go up, people drive less and purchase more efficient vehicles. As prices go down, the reverse happens. Historically, energy was produced by cogeneration. This system captured the heat used to generate power and used it for heating homes. As cities became bigger and power plants were moved outside the cities, this became less and less common. Recently, though, there has been renewed interest in cogeneration. By far the most common source of sustainable energy generation has been by the use of solar cells. This sun provides more energy to the earth in a day than we could possibly use. This makes solar a reliable, cheap source of power when the sun shines, of course. As more and more people have transitioned to solar, the cost per kilowatt hour has declined. In some parts of the U.S., it is so low, it is more cost-effective in the long term to switch to solar. A map of average solar radiation. When people think of solar, they typically think of solar cells used to produce electricity. However, solar power can also be used to heat things. This heating can be passive, like greenhouses holding heat or adobe houses holding heat, or active, where water is pumped through pipes. This active heating can not only heat homes, but also produce hot water to be used in the home. Electricity is produced by photovoltaic cells. These cells use different metals to transfer electrons when bombarded by the sun. This movement of electrons produces electricity that can be used to power appliances once it is converted to AC current. The power they produce is initially in DC current. As mentioned earlier, this process has become much more efficient with the cost to produce electricity, rivaling conventional sources. During the past 25 years, efficiency of energy captured by photovoltaic cells has increased from less than 1% of incident light to more than 15% in field conditions and over 75% in the laboratory. With further research, experts believe the cost by 2020 could be 10 cents per kilowatt hour, making solar competitive with fossil fuels. At least 2 billion people now live without electricity. This could be a solution to their problems. A photo of a house with photovoltaic roof tiles. The invention of amorphous silicone collectors has allowed production of lightweight, cheaper cells. Roof tiles with photovoltaic cells can generate enough electricity for a home. While not as common as solar power, wind power is becoming more common. Wind power has a lot of potential to produce a lot of power. When operating at full efficiency, wind turbines can produce very cheap power. However, they do not work everywhere like solar. They require a wind that blows steady at a speed of at least 10 miles per hour. Many areas of the country don't receive this wind energy enough to make wind power feasible. A photo of windmills in the U.S. Wind power pros and cons. Pros: no fuel costs or emissions. Generates income for farmers who rent land for turbines or sell electricity. Short planning and construction time. Cons: intermittent source. Not enough wind everywhere. Bird mortality. Power lines needed to transmit the electricity. A map of wind resources for the continental U.S. Biomass has been burned for centuries as a fuel source. The most common source of biomass energy is wood. However, any plant matter can be burned to produce heat and electricity. Additionally, biomass can be converted to methane through anaerobic digestion. As mentioned earlier, this methane can be burned to produce electricity. As recently as 1850, wood supplied 90% of the fuel used in the United States. In poor countries, it is still a major source of energy, and its use can result in habitat destruction. Even in rich countries, wood-burning stoves are becoming popular in response to rising oil prices. The Danish islands of Samso and Aro get about 1/2 of their heating from agricultural wastes and biomass crops. Some utilities are installing flex fuel boilers that burn a mixture of coal and biomass. Methane is the main component of natural gas. It's produced by an anaerobic decomposition. Burning methane produced from manure provides more heat than burning dung itself, and leftover sludge from bacterial digestion is a nutrient-rich fertilizer. Methane is clean, efficient fuel. Municipal landfills contribute as much as 20% of annual output of methane to the atmosphere. This could be burned for electricity. An illustration of anaerobic production of methane. Cattle feedlots and chicken farms are a tremendous potential fuel source since wastes contain more energy than all the nation's farmers use. Hydropower is not a new technology for producing power. In the U.S., many reservoirs were created in the 1930s to generate electricity by spinning turbines with water rushing through the dam. Dams have the potential to tap unused sources of power. Unfortunately, while they are renewable and do not emit air pollution, they can have serious impacts on the environment. For example, placing a dam on a river converts the ecosystem from a flowing system to a standing water system. This can cause drastic changes in the fish and plants found in the water. Additionally, they impede the movement of migratory fish, reducing breeding success for these species. A photo of hydropower dams producing clean energy. Much of hydropower in recent years has been from enormous dams. Human displacement, ecosystem destruction, wildlife losses, large-scale flooding due to dam failures, sedimentation, herbicide contamination, evaporative losses, nutrient flow retardation. Unwanted effects of dams. Rotting of submerged vegetation kills fish, acidifies water, produces greenhouse gases. Schistosomiasis, a human disease caused by parasitic fluke that live in snails, which like the slow-moving water behind the dams. Indigenous peoples lose their land. The earth can also be used to heat and cool homes. This is done by drilling deep wells and running water in lines into the well. This can be used to both cool or heat a building. Because the Earth's temperature is relatively constant, this form of energy has the potential to be used indefinitely. An illustration of geothermal energy. A newer method of producing power is by the use of tides and waves. Tides and waves contain huge amounts of energy. This energy is based on the wind and the moon and are also almost unlimited. Tidal power stations allow water to flow through tidal gates to turn a turbine. Energy is produced at all times except at high tide and low tide. To work, these systems need a high tidal excursion, or difference between high and low tide. This difference needs to be several meters. This only occurs in certain areas of the oceanic coast on Earth. Wave action can also produce energy. Wave converters convert the up and down motion of the waves into energy by causing fluid to be pumped into motors that drive generators. This system only requires consistent waves and does not rely on extreme tidal differences. Finally, differences in ocean temperatures from the surface to the bottom can be used to generate electricity. While a temperature difference of 20 degrees Celsius is needed to generate power, this is easily obtained in many areas of the ocean. This system works in a similar way to an air conditioner, where a gas is compressed and evaporated repeatedly to spin turbines. Regardless of the source of the power, transmission lines are needed to move the power. More money needs to be spent on our distribution networks to move the clean power from the point of production to the point of consumption. By doing this, sustainable sources are poised to replace conventional sources as we move forward. A pie chart of renewable energy scenario for world energy consumption in 2030.